Great. So let me give a quick background. So Vish, as the CTO and principal data scientist at DIVERGENCE.ai, Vish Puttagunta helps companies incubate data-driven teams centered around predictive maintenance, process mining, AI-driven robotic process automation. That's that RPA we were talking about a moment ago. Document processing and marketing. And as a co-organizer for DFW Data Science Meetup, Vish also enjoys organizing talks centered around data science and mentors students and professionals transitioning into the field of data science. If you guys help me welcome Vish.
Hello everybody. What a crowd, like with 40 people over here, and we covered everything from IoT and predictive maintenance sensors to process and fleet management to banks to everything in between, and the analytics piece as well. So welcome everybody. So my name is Vish Puttagunta, and I was an electrical engineer. A lot of embedded systems, a lot of signal processing background, based on image processing, whatnot. Worked with Steve and Kevin McCoy a long time ago. And about 2014 or so, I decided that I'm going to become a data scientist because everybody that I talked to said, oh, we're drowning in data, we don't know what to do with it. And I'm like, that's what I did with small devices. How does it work for big devices or big enterprises? So after struggling for a year and a half, I joined as the third student of Divergence Academy, and my mentor, Shravan, he's my CEO as well. He trained me as a data scientist in the enterprise. And 6 months later, I joined AT&T, and November of last year, I quit AT&T and joined him and co-founded DIVERGENCE.ai. So I'm the chief technologist at DIVERGENCE.ai. I'm also the director of data science programs at Divergence Academy. And today we're going to be talking about leadership. I once asked my, one VP of engineering, what does it mean to be a leader, right? What is the difference between an individual contributor like me and a leader? And his answer was, individual contributors definitely contribute a lot, but the leaders actually understand where they're heading and set up the right processes in place so that they can scale. So that was actually pretty powerful for me. So today we're going to talk about leadership and management and what kind of questions we should be going after to set the right processes up for big data and data science projects, especially with IoT. There's tons and tons of telematic data coming out, a lot of video data coming out, as she was mentioning about what tensor, edge tensor, is that right?
Yes.
So a lot of data moving around, and we're going to generate a lot of data. Like, one of the chief data scientists at Toyota Connected was mentioning that they generate something of the order of 50 gigabytes per car per month. And I don't even want to hear about what Tesla does. So, from a data science perspective, right? This is the holy grail. You want to go from an IT organization has always been a burner of cash, right? If you look at traditional IT organizations, they had a budget and it was always looked upon as a cost center, right? Even strategically they were important, yeah, but it was always almost a cost center as opposed to like a marketing or finance or operations or whatnot. The objective is to convert from a cost center to a revenue generation center. Just how do you take the cost of taking and maintaining the data to how do you productize it and actually gain, make that into a money-making machine or a value-generating machine. So what is the problem? And I'm not going to go into all the tools, but I'm just talking about the back-end data. Like, there are a lot of IoT data and they're streaming a lot of data, but this is a rough estimate of what was happening back in 2006, 2007, when data warehousing actually became a term. When people wanted to ask higher level questions, how many phones got sold, how many break-ins did we have, or things like that. They had to aggregate a lot of information and ask higher level questions. So there were these ETL tools like Informatica or whatnot, and then there was these big data systems called Vertica and Teradata and whatnot. And people used to visualize the data in Tableau or something like that. And a lot of statisticians would look at SAS. There are all these programs that used to run on a laptop. They wouldn't really scale to a huge cluster. And people from electrical engineering, we use MATLAB, right? And then we used to simulate everything, and then we used to scale it down. Whereas in SAS, they would scale it up. It was literally the only difference as far as I could tell. So the number of tools that were actually in existence was not like increasingly exponential, right? I mean, right now, and I'll talk about that a little bit. And along at about 2009, 2011 came the Hadoop ecosystem, which revolutionized. Now people could cheaply analyze billions of rows of data, right? And then the open source revolution kept on evolving, and there was Python and Pandas, Apache Kafka, all of these, Spark. These all came around 2009, 2014. But then the ecosystem started exploding, right? I mean, if you want to deal with text analytics data, you have to deal with Elastic, LucidWorks, Spacey. If anybody from operations background over here, somebody said fleet management, operations background, supply chain, we have tools like Solonis, ProM, Disco. These tools came literally in the last 2 to 3 years. Everybody's heard of deep learning, and I'm almost tired of it, but there's TensorFlow, came out just in 2015, November, right? And deep cognition is a tool that one of the developers here in Texas Instruments, he went and started a company that we use, and H2O. And if people come from a lot of statistics background, and they want to apply statistical algorithms, R is still the king, and H2O is another scalable tool that statisticians wrote. And there are distributions, Hortonworks, Zoom Data, Cloudera. And a lot of the work that I do is also getting automated, like all the feature selection, all the model parameters, what model selection itself, like which model should I use for what kind of problem. And then there are multiple cloud vendors, right? IBM, Azure, AWS, Google Cloud Platform. And that is the problem that the enterprises are facing today. In general, everybody is facing today is the political world of tools. In the past, you would just basically go and formulate your deals with SAS and Oracle, and for the most part, people were happy, but you can no longer ignore these tools. And how do you, and these are the tools that we at DFW Data Science got exposed to in the last 1.5 to 2 years. This is not even the tools that are out there. This is just our own community that got exposed to all these tools, and we had speakers come and talk about these tools. So, from a data-driven culture point of view, I've been working at, I work from startups. I am in a small company right now. I work for AT&T, all these big companies. If you look at what is actually needed for a data-driven culture, right? You need the executive vision. You need the people who can actually do the job. Data scientists, data operations developers, DevOps. And you also need the leaders that actually can set up the process to execute this vision, right? And a lot of times, this is what's happening right now in the city. You have people want to do AI, but their teams are not ready yet. Or sometimes we have data scientists who know a lot of the science and the math, but the executive team and the processes are not set up yet to take advantage of this. Right? They will basically say, oh, I'm sorry, we only have Hadoop. Like, what about this other tool? Hadoop doesn't support this use case. Oh, we only have Hadoop. Right? Things of that nature. So really what you need is something, without the executive vision, obviously nothing will happen. Right? You won't even get the funds for it. So obviously you need the data scientists, the data engineers, and DevOps to actually do the work. But most importantly, the leadership, I'm talking about the managers, the directors, the VP, EVP level people, they need to rethink about how this world is changing and how do we think about setting up, redoing the processes and make them evolve very, very rapidly. So this is kind of a typical enterprise project life cycle. And one of the things that I'd like to call out is everything was, at least when I looked at the enterprise world, I looked at my last 14, 15 years of my career, a lot of it was very requirements driven, meaning that the business users came and said, okay, this is what we want to get done, spec it out with probably one architect. There would be like an enterprise architect or some kind of a high-level architect, and he would basically say, okay, this is how the data should move, this is the kind of tool that we need to use. And then, the blueprint would be given to some developer, so that's why you have these ridiculous titles called Hadoop developer, Tableau developer. It's just a tool, but why do you have that? It's because the blueprint has been set by these architects as to this is what we're going to use. And then there was a whole testing team. And typically the feedbacks on a good day were 6 months, 6 to 8 months typically on a good day. So it was really, the risk tolerance was really low. Like everything was expected to work in the first shot, right? So that's why it was not uncommon to take 2 months to write a requirements document. And because of that, the attitude towards failure was also not upcoming, right? I mean, everything was just expected to, what do you mean it doesn't work? It's supposed to work on the first day. So the risk tolerance went down quite a bit. Everybody's afraid to take that risk and basically say that, hey, we didn't think about this scenario 6 months ago. We just had no way to think about this scenario because we never saw it. And there was little choice of the tools for people working in the ground. This is what frustrated me the most when I was working in data science, is that we know the data, we see the data, we see the patterns, and I know what tool to use, but the life cycle was just too much. What is a data science project life cycle? Compare that to a data science life cycle that's actually possible only now. Data science is not really new. It's centuries old, right? I mean, like even now we use Bayesian algorithms and logistic regression algorithms that were invented back in the 18th century or whatnot. Nothing is really new. But the pace at which we're able to move and the scale at which we're able to move has dramatically changed in the last 2 to 3 years. And it continues to change at such a dramatic rate even now. So, how have the processes evolved? So, when we started DIVERGENCE.ai, we were like, we're not going to worry about the requirements document. We're going to go to a customer and basically directly ask, what are the business objectives? So, for example, let's just take a simple example of JCPenney or somebody like that, right, a retailer. The first thing that they want to do is, hey, we want to make the customers come back. That's a very solid objective to have. And then we want to increase the margin per customer, right, the profitability. And then we want to increase the market share of retail, right? This is solid objectives. At least once you have the objective, you know how to quantify it. And then, for the first 3 to 4 weeks, this is what we're doing, right? We're not really writing down any requirements, but we go with the domain experts because, I basically probably know about machine learning, AI, and marketing a little bit, but I don't know about the specific retail clothing industry. I don't know about the restaurant industry, or I don't know about a specific domain. So it's very important for us to sit down with the domain experts and ask them, what does your gut say? Where do you think the signal is? A lot of times, point of sale data has tremendous amounts of signal. Initially we were like, let's just do clickstream analytics and this NLP analytics and things of that nature, but we found a lot of signal right in the point of sale data. Demographics. Aisle tracking, for example, we have a lot of cameras now, a lot of sensors tracking the data. We just at least identify that, hey, these are all the data that's available that can help solve this problem, right? We're looking at, can it help solve this problem first? Clickstream data, whatnot, and this data can be coming from various places, like Vertica databases, Amazon Redshift, it could be coming from Azure data warehouses or whatnot. It could be coming from many sources. And if you say, let's just get all this data and figure it out later, then you're going to end up with a data swamp. And that's what ended up happening. I've literally seen companies dump 70 to 100,000 tables from a Vertica or a Teradata into Hadoop and figure out, let's figure it out later. Everybody, the people who were getting the license per year licenses, they were really happy, trust me. But if you ask, what is the value? There was little value that actually got achieved. So what we do is we're very careful because we always think about what is the objective, what can we do in 12 to 16 weeks to achieve that objective and work backwards. We want to get to a minimum viable product in 16 weeks. That's our target. That's it. So what can we do? I don't care if you move the needle by 0.5%, but if that's what we can do in 16 weeks, that's what we'll do in 16 weeks and figure out what to do next. So the choices of the data set, we're very careful. We ask the domain experts, where do you think the data is? In the first 2 to 3 weeks, we work in the, we get the data directly. We don't move the data linearly. We just are taking the data, analyzing the data, and seeing if there is a signal that can help us with the final objective. And then we work with the domain experts and we look at in the first pass, what is the low-hanging fruit over here, right? Lowest effort, highest impact. It is almost, I'm almost shy to admit that the most money that we've made in companies, we use logistic regression and Bayesian regression. These are algorithms that are like centuries old. And why is that? We were just able to frame the problem and scale the problem very effectively. And then we focus, like once we decide, okay, we communicate, there's actually a way to communicate with the executives. I'm going to go over that in a little bit. But once we get the decision, usually it's the domain expert or the EVP of marketing or we see some kind of EVP of operations or somebody at that level that we have to convince that, hey, this is what we're going to do with each of our customers, or this is what we're going to do with each of our order that is coming in. They need to buy in. We can't just say, oh, we're going to apply this in a deep learning model and nobody knows why it is happening, why it is making the decision. That's not going to fly. They need to be convinced that this is the execution is meeting the intent. So within 12 to 16 weeks, we hit that first iteration. And we did this multiple times. Even in large companies like AT&T, the only projects that succeeded are when we just had a small team of 4 to 6 people and madly rushed to put a product in the hands of an EVP of engineering or EVP of marketing and built a data product. Not an analysis about this is what we think is happening. No, this is a product that is helping make a decision. Whether we're going to buy this or that, or we're going to send this offer to the customer or another offer to the customer. And then, once we know that the needle is in the right direction, because at the initial phase, I would always say start with linear regression or logistic regression, because you at least know if you frame the problem correctly, if you framed your features X's and Y's correctly, and then you can always improve on the features, and you can always improve on the precision and recall and so on and so forth. Yeah, and the visualization, especially interactive ones that I'm going to walk you through, they were really the key differentiator. Like when previously I used to communicate with other data scientists, and we were doing a lot of matplotlib and things of that nature, but when we had to talk to executives, as soon as we started scrolling up and down our screen, they were losing us. Because we looked at the data for almost 3 weeks, 4 weeks, 1 month, but we only had their attention span for 5 minutes or 10 minutes at the most. And in that time, we have to convince them that what we're doing is in alignment with their business objectives, and we need to get a buy-in that this is what we're going to do. So for us, interactive intelligence was extremely important at scale, not on a CSV file, at scale. So performance becomes an issue, right? Because I keep telling people, like, if an executive asks a question, you have less than 30 seconds to answer it. If you're taking longer than that, if your query times are longer than that, I don't care if it's 1 billion records, are longer than that, then the question will not be answered in that session, so you cannot get that knowledge into the model, right? We absorb a lot of knowledge from these domain experts. Because sometimes these guys don't even know what this is called precision, this is called recall, they just don't know it. But they know in their gut, Vish, something is not right about this. I know our customers. I've seen them for like 5 years, 10 years. They just don't behave this way. So for us, absorbing that knowledge back into our data science models is extremely important. And once you deploy the model is really never done, right? You want to make sure that you're monitoring it for, first of all, security is super important. And I'm not just saying it for the sake of saying it. I literally, in our company, we ban downloading any CSV files in an enterprise. Because once you download a CSV file from a database, all the security firewalls that the IT works so hard to put are all down the window, right? So you need to pick tools that actually inherently support security, and we directly work on the cluster of the compute. And the main thing is we focus on the problem, and then we believe that the tools will just appear. Like we have basic tools, Python, Pandas, Spark, whatnot. But beyond that, we don't actually say, oh, we're going to use H2O, we're going to use Celonis. We don't ever do that. We basically say, let's figure this out, let's solve it in the most naive way possible, and then the tool will just come to us. Like, as a matter of fact, I keep telling people, like 2 months ago, I was responsible, my CEO said, we need to fill this Divergence Academy full-time cohort. So it's essentially marketing and sales. A lot of times I even had a hard time coming from an engineering background, where does marketing end and sales start? I didn't know the whole marketing and sales life cycle. And I said, okay, what tool do you use? I did not even heed my own advice. So 3 months ago, we started using HubSpot, right? And the thing is, I was like, I didn't know what that really does. Meaning that I didn't know what it was actually automating. In the end, I had to understand, how is a student or a professional changing careers? How is he thinking? How does he actually make a decision to join a specific course? Me and my other director, we were getting into fights because we were like, oh, you didn't follow this process, you didn't follow that process. But we didn't even understand what is the process that we're trying to even standardize on. After a month or so, I'm like, why are we not following our own advice that we give to our enterprises that we go work for? Throughout all the tools, we went to Google spreadsheets, we went to Python and Pandas, did everything manually. We entered everything manually and we said, okay, is this gonna work? And every day we would basically sit down. 2 months of this, our class is not full. Everything is in Google spreadsheets. People ask me, what tool? I say, no, I sent emails to every single prospect. We went over to 2,600 prospects right here in Dallas. We meticulously did it. And the tools came. There was apparently a tool called LinkedIn Helper that can automate sending these messages, right? It was not a HubSpot. In the end, we did not actually use HubSpot. We actually used LinkedIn Helper quite a bit. And then we use a lot of Python and Pandas because we can just do a lot of manipulations ourselves. So focus on the problem, work backwards, the tools will come your way. Because the tools are evolving so rapidly, it doesn't make sense for you to really stick to a tool at all. Don't sign any contracts with any tools, first of all. And why the cloud, why the Docker, right? This was actually not even possible a few years ago, right? Because traditionally, if I went to an enterprise and I basically said, okay, for this time series problem, Spark ML doesn't solve this problem. There's no modules. If I have to develop these algorithms from scratch, it's going to take forever, but H2O has it. The life cycle of that used to be somewhere in the 12 to 18 month cycle. I mean, now I actually do sales a little bit, so I understand the pain of the sales people and marketing people quite a bit. But that's how long it took. And in the end, I cannot guarantee that that tool is actually going to be useful. What if that tool doesn't work? Then I'm always saving my ass, right? Like trying to protect that tool and making sure that this tool actually gets used. But frankly, I don't know. I don't know if that tool is actually going to work. I want to try that tool out, right? And that's why cloud, at least Dockerization is very, very important. As an example, right, in AT&T we were analyzing about over 100 million to 200 million click events every day. And there was this gentleman that came from LucidWorks and he gave a brilliant talk on how do you analyze click, whether it is text analytics or click analytics, how do you see patterns. Within a week, I deployed the entire pipeline in my laptop, right? So I was still more in the data sciencey space and I had this veil on myself saying that, okay, rest is data engineer's job. So within 1 week, I set up everything and I basically said, okay, this is the use case. Pretty much the POC was done. I was like, okay, let's take this to production. But I forgot to think about the admin of that cluster. He had all the components on the same cluster, the same LucidWorks and whatnot was working on the same cluster that the Spark was, on an on-premise cluster. He had tons of production jobs running in production. So it's not like if this particular thing needed a particular Spark library or whatnot, we don't know what it's going to do to the rest of the ecosystem, right? Are there ports that are going to be colliding or whatnot? Kerberos support, you need enterprise support, right? Anybody can do anything on a laptop, right? When you get onto an enterprise, if you don't think security first, it's pretty much of no use. And it took even the best of the engineers that I used to work with about 3 months to configure the tool. 3 months. They actually had the license. It took because they never worked with this new tool. It's a new tool. They've never used it. And of course, the licensing and license support, because initially we only had licenses for about 10 nodes, and we saw that, hey, with this kind of data, we at least need about 25 to 30 nodes, and there goes the project life cycles. So what the cloud really does is once you segregate the data from the compute and isolate each service, And you're able to bring up the service when you really need to. And that is a unique advantage that the cloud actually provides us. If I need H2O, I put the data in the cheapest way possible, because a lot of times in IoT, you don't know where the value is. There'll be machines running for years that will never fail. What are you going to do? Are you going to just put everything in your Azure Databricks warehouse or something like that that's actually expensive? Or are you going to start putting it in the cheapest way possible, figuring out where the signal is, and then say, okay, if I get that thermostat reading and that pressure sensor reading, I think we have value, then put it into a little bit more expensive data warehouse that can give you answers quickly. And bring up the clusters on demand. And what's happening right now is if EC2 instance costs about 24 cents to rent, what these tool vendors are doing is they're just upcharging it to 27 cents or 30 cents or whatnot. At which point of time you don't have to sign any deals. You don't have to talk to a single salesperson to actually use a tool. So now you can literally say, right, there were literally times when we took a $200, swiped a $200 credit card, processed the data for about a couple of days, and basically said, okay, this tool works or this tool doesn't work. $200. I mean, compare that with $140 to $150 million that companies do spend right here in the city on these tools and hardware, not knowing whether this is going to be in the right direction or not. So anyhow, so quick exploration just gives you a very, very fast way of doing things, and pay and scale on demand. When you actually need to scale, then you natively scale. So what is the key leadership management skill set that you need to have? Obviously, communication, constant communication with your data science team and your data engineering team, and understanding, are they going in the direction of the business intent? And how do you do that? Interactive visualization that is interactive, scalable, and secure, right? And typically, our tools of choice at this point in time, Tableau, or Power BI, or IBM Cognos, that's just at a point snapshot in time. Tomorrow, we don't know what's going to happen. Domain knowledge, absolutely a must. Make sure that business is involved. We actually don't even involve in a business unless the business is involved. There's finance, chief of finance, or chief of marketing, or chief of operations. They need to bless off this project. Otherwise, we're just doing science projects. And how do you measure does the execution align with intent? A lot of people, especially the directors, VP level people, they say, I don't need to know data science, but there are parts of how rigorously you can test your assumptions. Even the leaders need to have that. You don't have to know how this specific algorithm works or that specific algorithm works, but you absolutely need to know how are the underlying distributions, right? If you randomly pick somebody, you have to start thinking in probabilities, because you're no longer dealing in, this is the cutoff and everything beyond the cutoff is always going to be red and this is always going to be blue. It's never going to be like that. You're going to deal with probabilities. So your mind has to start thinking in probabilities and risk. You have to understand at least the basics of how to do univariate and bivariate analysis, meaning that, like, how does age, like if I randomly pick somebody, what is his age going to be, what is his gender going to be? You have to understand the underlying distributions. Performance and precision. So you need to know, if somebody just gives you a model, how do you compare that to the benchmark? How do you even measure this? And is this better than the other model? And what insights is this model also giving? Does it explain why it's making the decisions it's making? Application isolation, this is more of an operations. And I cannot stress more on application isolations. I've seen literally hundreds and hundreds of POCs and less than 10 actually making to production. This is real. So when we go in, we're building a data product, we're building it at scale. We're not doing Python pandas, right? We're not doing a Jupyter notebook. Everything in the end is a software that runs on a machine, right? So that's the level where, we are driven by, like a product-driven mindset. And you need to know cloud basics and security essentials from everybody, because the moment you download something onto your laptop, you're compromising a lot, right? So from a leadership perspective, this is really important, because this is a different world. This is a world that we have not seen in the last 10 years. So we cannot apply the same rules and think that, okay, let's just hire an army of 200 people to do this. That doesn't work. We went and displaced a 14-year-old marketing company in less than 16 weeks. That's what we did. So numbers really don't matter in this world anymore when you have the cloud. the quality really matters. So anyhow, without any further delay, I'd like to explain. Any questions so far before we get into the visualizations? Crickets. Okay? That good. So, from a visualization point of view, right? There could be a lot of algorithms going in the backend, right? So, and this is how we as data scientists communicate with the executives of marketing, or, like for example, let's just assume that we're in IoT kind of, not IoT, but security, right? So let's take this one example. One second. So this is an example of, by the way, how many of you use Google Docs? Okay, if you use Google Docs, that is Google Docs, and now you have the entire power of machine learning for the same price included into Google Docs. That's actually a Jupyter notebook over here. It's an environment that a lot of the data scientists for analysis actually use. And now, essentially what this is doing is Google is spinning up a container for you that has all the machine learning algorithms in it, libraries and everything like that in it. And they're giving you a web link so that you can actually do a lot of the analytics. So if you have data anywhere, you can just suck up the data into that container, do all the analysis, and it's all completely secure. Like it's authenticated and everything. You can access data on your Google spreadsheets. And this is what we did for our CRM. We had that spreadsheet was our database. We didn't even have an Oracle database. Why do you need an Oracle database for 2,000, 3,000 people? Let's just start somewhere. Let's get the results first. Let's see what works, right? So this is what we ended up doing. This is what we do every day. It was like, what did we analyze? How many people did we tag? How many people did we contact? What did they say back to us? Was anybody happy about it? Was anybody grunting about it? Took them off the list. Decisions in real time every day. So this is an example of ham and spam. This is a very easy example to explain. I know IoT is I was having a challenge explaining an IoT problem. I think this is a little bit more easier problem, but the higher level questions are, how do you make sure that the data scientists are doing what the business wants, right? That's the higher level question. So ham and spam is a very simple example that kind of shows that, say for example, you're doing a security product, right? And you're scanning every email or text message that comes in, and it's going through this filter, and you're trying to see if it's a good email, a ham, or a spam, right? So if you look at this, you can kind of say that, hey, go until Jerome Point, crazy, available only. That's a good message, right? Seems like a good message. And free entry in 2 weekly comp to win FA Cup final. What do you think? Right? And somebody, say for example, you as the business owner already paid somebody, paid experts. Sometimes it's easy. Sometimes, ham and spam is fairly trivial. But if it's a cancer, non-cancer, you need the price of tagging exponentially increases. There's a cost associated with it. There's a bias associated with it. The bias starts right here. That's why you need a diverse set of people tagging your data. Initially, I was tagging the data. So I was looking at electrical engineers, network engineers, and so on and so forth. We hired an intern. She was coming from an economics background, and she said, Vish, why are you not looking at marketing people? That's where bias crept in, because I looked back and there were about 100 people that I completely missed. How will my machine learning know it? I'm the guy who's teaching it, right? So that's where bias creeps in. People talk about bias, but this is exactly where it starts. Who is training the model, right? And so for the first 2.5 weeks, we explored this data and we came up with the machine learning model. Forget about what the machine learning model is. Let's just say that, Mr. Jack, you're the executive and I'm the data scientist. Let's play this card. So in the last 2 to 3 weeks, we built a model, and we want to make sure that first of all, our model is achieving the objective. What is this? Essentially, you see each of these is a message, right? This is a histogram. Like, our model basically said the likelihood that a particular message is a ham or a spam. It will give you a probability, right? And along the probability, if you put the histogram or whatnot, that's what my algorithm said. All the ones that are blue, my model, and I put the threshold at 0.5, so the cutoff is at 0.5. And my model said these were all good messages and these were all bad messages. That's what my model thinks. Now you tell me, is this in general doing a good job? So let's go through the good messages. Handle Victoria Island in traffic. What do you think? Looks like a decent message? Yeah? Just look at a couple of them. Suspicious but okay. So overall, there are a couple of questionable things in there. But anyhow, so, but the bad ones. Oh, sorry. What do you think? Right? So, in general, Jack, am I doing it? You think it's going okay? All right. So that's how you, first question, is the intent, is the execution meeting the intent? Okay, overall, at least I understood your problem correctly. I'm not, trust me, there are a lot of us data scientists, we get very, very attracted to some ARM badnet solutions or genetic solutions, and we get carried away. Your job to keep us back on track and say, Vish, did you solve it with a simple stick? Okay, if a stick doesn't work, then we'll go to a bazooka or a gun, right? Great. And then a confusion matrix, like, these are all the, let's just say that these are all the bad guys, right? And these are all the good guys. These are all the good guys, and my model said correctly that they're good guys, right? These are all the bad guys, and the model correctly detected that they're the bad guys. This is called a confusion matrix. Super important. And these are the bad guys that my algorithm did not catch. And these are the good guys that my algorithm actually said they were bad. So now, are you in marketing or are you in risk? You have to think differently. Same algorithm, same logistic algorithm or Bayesian algorithm or neural network. I don't care what algorithm it is. You have to tune it differently. For example, if you're risk, you're like, this number has to go down. You know that intuitively, right? And our visualizations represent that. For example, the way that we highlight.
But that's going to depend on your business, right?
Right.
Because that might be a fully acceptable for
It might
some
be.
businesses, and for others it could be life-threatening.
Right. For example, in marketing, do I care if I send an email and that guy doesn't respond? A little bit, but not as much as the
Not as
security
much
expert.
as you send
Right.
data to a doctor and
Right.
it's the wrong data.
Yeah, at least nobody's going to die. I know that people are not going to die. So what do I do? So we have what are called recall and precision. Recall is like how many of the bad guys are you catching, right? So I know that I'm catching 96.2% of the bad guys, right? Once my model said that this is a bad guy, how confident am I? That's what precision said. The formulas are very confusing, guys, but there's a very intuitive story behind these numbers. And I show this to any business executive, they just get it, usually, right? And once I explain to them, oh, Vish, if you're a security expert, you probably say, hey, I'd like to get more of the bad guys, right? 21 is not a bad number. Overall, it's not a bad false positive rate, so it's okay. I think we can, so we tune for recall. That's what we do. How do you tune for recall? Even without going back to the algorithm, I can just literally change this cutoff parameter to like 0.2 and look at that number from 96.52, go up to something like, so this is how we can play. Right now it's giving a query and it's hopefully gets me back the result. But essentially that's what, you can immediately Wi-Fi. Yeah, these are all the, okay, so see that? It went from 95 to 96.92. Very quickly you can actually see, okay, even just varying the threshold of the probability, you can actually get some improvement. And then you can ask me, can you please help me? Where am I messing up? If I click on that, immediately the visualization responds in near real time what is actually happening, right? So now I can say, so I'm saying that my algorithm I did not capture that this is a bad message, right? My algorithm still thinks that these are good messages, but these are actually, you paid some domain experts and they said that it was bad. So let's look at that. Not hurtful. So that's actually a pretty sophisticated bad message, right?
We can't
So-
see it, so.
Call me now,
So-
I'm here all night with just my knickers on.
Yeah. Right, so these are a fairly sophisticated technique because a lot of the words, like now I actually use very naive technique. It doesn't look at the sequences of words that are coming in. It's a very naive technique though. But it still was fairly accurate, right? I mean, it was getting 96% there. So at least we know we framed the problem correctly, right? And now we know what we have to do to make this right, or to properly classify this as a bad message. So at least I have feedback that I can give to my machine learning model. I need to take some of these messages and keep training them that they're bad. And sometimes they're actually legit messages. So this is actually a good message. This is where bias comes in. Why? Because your tagger that you paid to tag the information, that person said this was a bad message. So it's not really my algorithm. My algorithm probably detected it right. The data itself is flawed. It's flawed a little bit. And that's how we drive the insights in a very communicative way. Have I scrolled at all? I haven't scrolled a bit. And this is what we notice is that executives, you don't want to lose the context, right? Previously what I was doing, I was basically, oh, this is how I applied my naive-based algorithm, and I applied this particular algorithm, and this is what my confusion matrix was. Look at the actual versus real, whatnot, and this is the precision, and this is the recall. And it was just going, it was like, Vish, what the hell are you talking about? Right? So we had to learn how to communicate with our, with our executives or managers, people who actually have a lot more domain knowledge than us, and drive those insights back into our models. That's what this means. And I know a lot of you are all from IoT background as well. Just wanted to showcase, this is one way of looking at the world, right? If you look at Tableau, it's one way of looking at the world. I keep telling it, a lot of the traditional BI reporting is really a group by and a partition by, for the most part, right? You're just group by and for the most part. But a lot of time processes a sequence of events, right? You have a meter reading. And this is why you don't want to get stuck to the tool, right? I hear a lot of times, oh, our company will go with Tableau for visualizations. What if the problem doesn't fit? So for example, when you have a process in place, this is a meter to cache reading, right? You create the reading document, you conduct the meter reading, you create the billing document, you create the invoicing, you print the invoicing, you change why the incoming payment and the due date is passed and whatnot. This is typically the workflow. Tableau is horrendous at visualizing things and stuff like this, and this is where we have to get to a little bit more process-oriented visualizations. But still, this will scale. You pick tools that will scale. You're not married to this tool. If there's another tool that comes in, by all means, we will use that. So, essentially what we're doing is, once you have a meter reading, you're tracking that bill across, right? This meter reading could be coming from an IoT device. It could be coming from a fleet management. And in that, if somebody's in operations over here, what is your primary concern? If you're the industrial engineers here, ERP, fleet management, supply chain, anybody? No? Okay. So, when you have a process, what is your number one concern?
The efficiency.
Efficiency. How do you improve efficiency? Where are the bottlenecks? Is the process fitting with our workflow, workflow fitting everybody's schedule or whatnot, right? So you want to know bottlenecks. So what you have to do is you have to look at, this is just one variant of the entire process, right? So you start looking, but this is the most common variant. 35% of the cases are going through this channel, right? So you want to look at, and you want maximum, but say for example you have a flow chart, you want to make sure that maximum amount of the cases are going through the happy path, right? But what about the other 5 or 6 variants? What is happening? And that's how interactive it is. This can scale to billions of records of time series data. But it's interactive, and now if I want to know where are the bottlenecks, I can actually start to drill down like, hey, how are people actually coming here? You know, for example, due date passed. How are people getting here? What are the causes, leading cause of this particular due date? I can look at it from a machine learning statistical point of view. Now that is like, I condense all of these into a table, right? I mean, there's a different way of looking at these problems. But if I apply traditional statistics, these problems are very, very hard to solve. But if I look at it like a process graph, these problems get extremely simple to solve, right? For example, I can just say, I just want to look at all the process variants that have this particular variable. And now I know all these numbers, right? I know all the different cases that are ending up in the due date past. That's how quickly we are able to analyze the data, right? And you can look at like where are the bottlenecks, you can look at time. For example, I know that this is the case frequency, how many cases are coming here versus here. But there are ways to instead look at throughput time, for example. So now we know where is the bottleneck.
What's the data behind this look like?
It's coming from, typically it's coming from Azure Databricks or Azure Data Warehouse, or it's coming from AWS S3 buckets or Hadoop systems or whatnot.
And then it looks pretty complicated.
It's actually not. It's only three things. The case, the activity. The case is like what we're actually following. The activity, each of these things is activity. And then there's a timestamp. That's all you really need for the most part for analysis. This looks complicated, it's not. It's only three variables that you're looking at. This is how we optimized our CRM. Because we were looking at, hey, at what point of time, let's look at, we worked 2,000 people. We meticulously, tagged these 2,000 people on LinkedIn. Let's look at the 27 people that came in, and we looked at the processes that actually, how did people end up here? And then we started doing a little bit more of that, right? And that's how this process works. It's actually very simple. But the thing is, you cannot say, if you start thinking, how can we solve this with Tableau? Now it becomes a very, very, very complex problem to solve. So anyhow, so I just wanted to kind of showcase like how this, the cloud and the sheer number of tools. Have anybody heard of Celonis before? No? Celonis is just one of the many tools in the space of process mining. Celonis, the idea of process mining itself only, there was a Professor Vandal Els, he only wrote the paper in 2006. One of the first algorithms that detected processes from the timestamp data only came in 2006, and they only got scalable because of the big clusters that we have now. But this tool...
But that's only true from a data analytics perspective. Because if you look at it from an engineering perspective, I mean, my dad was doing this kind of stuff as an industrial engineer a million years ago.
Really? They were doing process simulations. A lot of times...
No, he was actually doing this kind of work.
Scale,
But he was doing, huh?
At scale.
Huh?
At scale?
Well,
and how much did that cost?
How much did it cost?
Yeah.
One engineer with access to data. But what it was is he was doing the analytics himself. Yeah. He wasn't automating it through Celonis. He was using spreadsheets. He was using calculators.
The idea of process, right? I only, I saw this
when you began.
Right.
The whole process of doing analytics is not new.
Yeah.
It's being able to do it quickly.
Right.
Right.
Because I didn't understand process until I talked to an industrial engineer. I saw this and I'm like, how does this work? And like, how come nobody knows about it? And apparently I found that industrial engineers, that's what they do for a living.
That's what my dad was.
Right, and then I'm like, oh my God, I need to learn a little bit more about what they do and how do they think, the Lean Six Sigma, all these things came into picture at that time. And like, I started learning a lot of that.
I think it's a great point you make about taking the problem and then figuring out which tool. It's the old proverbial, if you have a hammer, everything looks like a nail. But the problem I see is, if you're just interested in the solution or figuring out a problem, knowing what tools are out there today, I need a guide, I need a consultant just to find out what the tools are today, or else I have to spend hours and hours reading through.
That is something that we struggle with every day.
And then next month it's a different, there's a new tool.
So that is the reason why we don't put too much faith in tools. So we have our basic tool set, like Spark, We just need to be able to manually do things, right, at scale. And we have some basic tools that do that, like Google Spreadsheets, the Python Pandas, the Spark. These are our basic tools, and we know statistical fundamentals. We've learned process fundamentals, right? I'm not an industrial engineer. I was fascinated when I saw this, and I didn't sleep until I understood how processes have worked. How did Ford come into picture? Like how Ford revolutionized this in like early 19th century, right? So anyhow, that's how we want. And then once you figure out manually, then your Google knows a lot of things. You'll start asking the right questions in Google. And when you do that, how did I find linked helper? I didn't talk to a sales engineer. I just was like, hey, you know, I'm now sending about 200 emails a day. Is there any way that I could semi-automate it? And now I start asking these questions, and LinkedIn Helper came at the top. It was actually the second tool that I used, not the first one, right?
I think you're lucky if you find the right tool. I know yesterday I was just looking at a simple problem like I want to create a website. Which technology? There's so many technologies out there.
Right. So
doing a website.
That itself is a wrong question, right?
Yeah.
I mean, that itself, I would argue that itself is a wrong question to ask. What are you trying to do?
I'm trying to build a website.
Right.
Now I got to figure out which tool to use.
Are you trying to build a website, or are you trying to sell a service to somebody?
I need a website. Because you just have to. It's like I need a business card.
Okay, so my Divergence Academy, Divergence.ai, go to our website. It absolutely freaking sucks.
I need a website. I didn't say it had to be good. I know, but I'm just an optimizer. I'm an optimizer. I need to figure out which tool is best.
But that's a classical
I
problem,
would say
right?
that's the backwards
It's
way.
always the
Right.
why, how, and what.
Remember when I said we fall in love with these algorithms, like, you know, ant problems or genetic algorithms? They're very sexy. They look awesome on my resume. Did they solve the problem for an AT&T? No, we burned like about $20 million. Right? It looks phenomenal on my resume. I could get whatever job I want if I put those resumes on the algorithms on a resume. So now I don't put any of the algorithms. Right? It's just a.
I think the whole point of this is you have to look at the problem from a different perspective.
Right. You know, we actually burnt, like, if you're a small company, I think you'll relate to this. We spent over $25,000 to $30,000 on marketing that gave us no results. How many of you have done that over here in this room? Right? Why? Because they come and say, oh, we're going to do social media marketing. We're going to do clickstream analytics. In the end, for what? What are we trying to sell? Why? What is the problem that these guys are trying to solve? Like, you know, we know that there's a person out there that got laid off from Ericsson. We know there's a person. Where are they sitting? Where are they lurking around? When you ask those questions, now you'll understand, how do I reach them? Sometimes you actually find that they're not in LinkedIn. They're sitting in a church in South Lake. Right? And that's where we had to go. Website would not have done anything for it.
So Vish, what's the risk of not selecting all the appropriate data sets to build your model against?
Ours is like, we fail so fast.
Yeah.
I keep telling them, like, you know, for example, when we went and replaced the 14-year-old marketing company in one of our clients, we told them we didn't succeed in 16 weeks. We failed 3 times in 16 weeks. So the risk is actually low when you can fail so fast. See, I worked on projects for 8 months and 9 months, and if it fails after 9 months or 1 year, the fingers will be pointing in about 10 different directions. If I fail in 6 weeks, people will point to me. It's okay. At least I know where the mistake is coming from.
And when you say you failed, you mean you built the model and then you brought in a training data set?
No, we actually deployed it. We actually sent the emails out and saw who responded. And it was a miserable failure.
Well, fail is really not the right way to say it. Because there's a lot of wrong possibilities. You know that those possibilities are not the right ones to pursue. So you're pruning your problem set, right? So I like to see it as, okay, you want to quickly know where not to go.
But the thing is, it's an experiment in production.
So,
It's not a science project. I am tired of Kaggle.
Can I help for a second? Maybe?
Yeah.
So we did the same thing with a remote monitoring system for a cardiac assist device. Okay, nobody knew what the doctors needed. Nobody knew what the doctors needed because there was never a remote monitoring system before for these cardiac assist devices. So what did we do? A programmer and I sat down and said, well, gee, what can we give them that we think is good? you know, what kind of pops up? So we started sending that to doctors. And then we'd ask them, is any of this any good to you? Oh, no, I wish I had that, but in a, you know, slightly different. And then we went back and changed it. In a period of 12 weeks, we were taking real data from real patients, going to real doctors, and in your terminology, we failed probably a dozen times in those 12 weeks because it took us about that much time to get the feedback back and then program it back in. And then we had a working system in 12 weeks that was wonderful.
Instead of
But
shoving
it's that
down,
vast failure.
instead of shoving down Watson every doctor's throat. If you look at IBM, I think that's one of the biggest things that they did wrong, is that they basically said Watson will solve all problems. And now if you look at IBM messaging, they're extremely careful about how they message things. I think they've learned a very, very harsh lesson. And we got to be very careful about setting expectations. And we'd rather have like, are we going in that direction? Just answer the, you know, if you just follow that one question, and if the cloud gives us the ability to provision something, take it down, and there's no best, you know, once you spend about $200,000 on a tool, you're attached to that tool. It's very, very hard to not be attached to that tool. You cannot think objectively.
Or if your boss goes to a conference and hears about a tool, comes back and says, here's a tool, go fix this problem.
With RPA, I mean, like, oh my God, I cannot believe that the entire RPA field. They'll be like, which RPA tool, UiPath or this or that? And I'm like, in the end, we have an RPA company, we use none of that. We use Selenium. And just programmed it, because in the end, none of those UiPath tools actually would automate things on the web page properly.
All right, one more question and then we'll officially end, but you're gonna be able to stay, right?
Yeah.
Okay.
I was kind of curious, a lot of people are talking about, you know, a lot of times the hardest, you can talk about the right tools or the right problem to solve, but a lot of the customers we talk to, they might have a lot of data, they might have the system in place, but they're having the hardest time figuring out what problem are they trying to solve. And
So
for
That's
us,
the key.
that's where, at least for us, we have to say, okay, can we get your subject matter expert? Can we sit in a room? Can we talk this out? I was wondering on your side, figuring out the problem to solve.
That's a business
So
problem though, isn't it? They don't know the problem they're trying to solve.
Yeah.
It's also a technology problem.
That's not a technology problem.
Oh, sure it is, because it guarantees your technology is going to fail.
So usually,
Yeah, but the problem is you have to solve the business problem before you deploy the technology. If you don't solve the business problem before you deploy the technology, you're just throwing all the money away.
Oh, you could do it together. I mean, we did it together.
Typically, they don't know everything that they have access to. That's what
they don't even know, like for example, until you saw Saloons, you probably, they need imagination, right? I mean, sometimes you know, executives need imagination. Oh, I didn't even know that this kind of problems could be solved this way at all, right? So expanding the imagination is one. The other litmus test that we have is, give us a use case that you're proud to show your CMO. Give us a use case that you're proud to show up for your CFO. That's actually going to end up in your P&L report. When you start with that level of questions, you get very good questions, because you know, when we go in, they're like next best offer or whatever. Like, you know, that is a use case, and driving the number of sales. These are hardcore things that if you are able to measure and succeed, they will love you for it. Instead of saying, give me all your data and we'll figure it out later, it's a disaster waiting to happen.
I'd say the same problem exists with mechanical iterations in R&D. So you're taking really a mechanical engineering approach in some ways to this, because you don't know what you don't know. And so you get into it, you know, I've wasted years and tens of thousands of dollars with people simulating a solution, and when you get it, the computer says it works, but it's not even close to being a real world product. And so it's better for us to rapidly iterate, break it, fix it, refine it. And it's not, I mean, that's what I'm gathering. That's the same approach as doing it with the analytics and software.
I would disagree with one thing you said. You said it's a mechanical engineering solution. It's just an engineering.
It's just an engineering.
Every single
But I've had the problem with software engineering and software and electronics and controls where they don't want to iterate. They want to.
The software engineer that you worked with don't want to iterate.
They're not good software engineers.
All right, let's officially call it an end. If we would give Vish a hand. Vish is welcome to come up